when Harvard University's most controversial astrophysicist started warning the world about an incoming interstellar visitor potentially carrying alien mini-probes, the scientific community exploded. Dr. Avi Loeb didn't just suggest that the newly discovered Comet 3 I/ATLAS might be artificial intelligence from another star system. He went further, claiming this mysterious object could be on a reconnaissance mission, possibly deploying microscopic surveillance technology as it sweeps through our solar system. The implications sent shockwaves through NASA, triggered heated debates in academic journals, and left millions wondering if we're witnessing humanity's first contact with extraterrestrial technology disguised as a simple comet. The story begins on July 1st, 2025, when the Atlas telescope array in Chile flagged something extraordinary moving against the background of stars. What appeared as just another faint blip in the night sky would soon become the third confirmed interstellar object ever detected entering our solar system. The discovery team initially catalogued it as a routine long-period comet, complete with the typical dust halo and carbon dioxide emissions you'd expect from a chunk of ancient ice and rock. But as the data poured in over the following weeks, 3 I/ATLAS refused to behave like any ordinary cosmic visitor. Moving at an incredible 58 kilometers per second relative to our sun, this interstellar traveler was racing through space fast enough to cross the distance between Earth and the Moon in just over 2 hours. Its hyperbolic trajectory confirmed what astronomers had suspected from the beginning. This wasn't a native of our solar system. Like the famous Oumuamua before it, 3 I/ATLAS had journeyed from the depths of interstellar space, carrying with it the frozen history of some distant stellar nursery. Initial calculations showed it would make its closest approach to Mars in October 2025, passing within 30 million kilometers of the red planet, while maintaining a safe distance of 270 million kilometers from Earth. For most scientists, 3 I/ATLAS represented an incredible opportunity to study pristine material from another star system. Early spectroscopic analysis revealed the expected signatures of water vapor and carbon dioxide, matching the chemical fingerprints of countless comets that have wandered through our cosmic neighborhood for billions of years. The European Space Agency immediately began coordinating observations with their Mars Express and ExoMars Trace Gas Orbiter missions, positioning themselves to capture unprecedented data as the visitor made its closest approach to the red planet. Everything seemed routine until Dr. Avi Loeb entered the conversation. Professor Loeb, the former chair of Harvard's astronomy department and founder of the university's Black Hole Initiative, has built a reputation for challenging conventional scientific thinking. His previous claims about Oumuamua being potentially artificial technology had already put him at odds with much of the astronomical community. When 3 I/ATLAS appeared, Loeb saw patterns that others dismissed as coincidence. In a controversial paper published in July 2025, he outlined what he called considerations which support the hypothesis that 3 I/ATLAS is technological. The Harvard physicist pointed to several characteristics that he argued were statistically improbable for a natural object. First, the comet's orbital path seemed almost engineered to provide optimal viewing angles of our solar system's major planets. Its trajectory would take it on close flyby missions past Venus, Mars, and Jupiter, exactly the route an alien reconnaissance probe might take to gather maximum intelligence about our planetary system. Loeb calculated the odds of such a perfect sightseeing tour occurring by random chance and found them astronomically low. But Loeb's most startling claim came during a weekend interview with Elizabeth Vargas Reports. The Harvard professor suggested that 3 I/ATLAS might not just be observing our solar system, it could be actively deploying what he called mini-probes designed to infiltrate Earth's atmosphere and conduct detailed surveillance of human civilization. These theoretical devices, according to Loeb's hypothesis, would be too small to detect with current technology, but sophisticated enough to gather and transmit data back to their creators. The scientific community's reaction was swift and harsh. Dr. Jason Wright from Penn State University called Loeb's analysis very, very bad science, arguing that the Harvard physicist was making extraordinary claims without extraordinary evidence. Multiple peer reviewers pointed out that every characteristic Loeb identified as potentially artificial could be explained through natural processes. The close planetary approaches, while statistically unlikely, weren't impossible given the chaotic dynamics of interstellar trajectories. The comet's composition and behavior matched established models for ancient comets that had been wandering through space for millions of years. Critics also noted that Loeb had a history of making similar claims that ultimately proved incorrect. His assertions about Oumuamua being artificial technology had been thoroughly debunked when subsequent observations revealed natural explanations for the object's unusual acceleration and lack of visible outgassing. Many astronomers worried that Loeb's tendency to immediately jump to alien explanations was damaging the credibility of legitimate SETI research and feeding dangerous pseudoscientific theories. The controversy intensified when media outlets began sensationalizing Loeb's claims, transforming his cautious scientific speculation into headlines screaming about imminent alien invasion. Social media exploded with conspiracy theories, while legitimate researchers found themselves having to constantly debunk misinformation about hostile extraterrestrial technology infiltrating our solar system. The situation became so heated that several major astronomical journals refused to publish follow-up papers on 3I/ATLAS if they contained speculation about artificial origins. Despite the backlash, Loeb remained undeterred, arguing that the scientific community's dismissive attitude toward unconventional possibilities was itself unscientific. In multiple Medium articles and interviews, he maintained that astronomers had a responsibility to investigate all potential explanations for unusual phenomena, even if those explanations challenged conventional assumptions about our place in the universe. He pointed to the historical precedent of scientific breakthroughs that were initially ridiculed by the establishment, from continental drift to the existence of black holes. The debate over 3I/ATLAS reflects a deeper tension within modern astronomy between cautious empiricism and bold theoretical speculation. While most scientists prefer to exhaust all natural explanations before considering more exotic possibilities, researchers like Loeb argue that this approach risks missing genuinely revolutionary discoveries. The question becomes whether the scientific method is best served by conservative skepticism or by maintaining what Loeb calls open-minded agnosticism about the nature of unusual phenomena. As 3I/ATLAS continued its journey through the inner solar system, ground-based telescopes and space missions gathered increasingly detailed data about its composition and behavior. The Hubble Space Telescope captured stunning images showing the comet's elongated coma stretching over 10 times longer than it was wide, with brightness contours that defied typical comet models. Rather than the expected tail pointing away from the sun, 3I/ATLAS displayed what astronomers called a sunward glow, scattered light that seemed to point directly toward our star in violation of standard comet physics. These observations provided fresh ammunition for both sides of the debate. Loeb's supporters argued that the anomalous light scattering pattern suggested artificial materials or structures that natural comet models couldn't explain. Mainstream astronomers countered that unusual optical effects could result from the object's unique composition or the specific angle of observation, pointing out that interstellar comets might behave differently from their solar system counterparts due to billions of years of exposure to cosmic radiation and interstellar chemistry. The European Space Agency's Mars missions prepared for the ultimate test of competing theories when 3I/ATLAS made its closest approach to the red planet on October 3, 2025. Multiple instruments turned their sensors toward the visitor, hoping to resolve the mystery once and for all. High-resolution imaging systems searched for any signs of artificial structure or geometry that might support Loeb's technological hypothesis, while spectroscopic analysis probed the object's chemical composition for unusual isotopic ratios or synthetic materials. Preliminary results from the Mars flyby observations showed 3I/ATLAS behaving much like any other comet, with standard outgassing patterns and typical rocky icy composition. The object's nucleus appeared to be roughly 400 meters across, consistent with size estimates based on its brightness and distance. No artificial structures, geometric patterns, or anomalous materials were detected, leading most astronomers to conclude that the interstellar visitor was indeed a natural remnant from another star system's formation. However, Loeb and his supporters weren't ready to concede defeat. They argued that truly advanced alien technology might be indistinguishable from natural phenomena, designed specifically to avoid detection by primitive civilizations like our own. If an extraterrestrial intelligence wanted to conduct reconnaissance of human civilization without triggering panic or defensive responses, disguising their probes as natural comets would be the perfect strategy. The absence of obviously artificial features, they claimed, might actually support the stealth technology hypothesis. The controversy took on new dimensions when amateur astronomers and citizen scientists began conducting their own observations of 3I/ATLAS. High-resolution photographs posted on social media platforms showed what some viewers interpreted as geometric structures or reflective surfaces within the comet's coma. While professional astronomers quickly identified these features as optical artifacts or background stars, the images fueled continued speculation about the object's true nature. Government agencies maintained their official silence on the alien probe theories, but leaked documents suggested that both NASA and the European Space Agency had quietly increased their monitoring protocols for 3I/ATLAS. Deep Space Network facilities allocated additional tracking time to the object, while planetary defense coordinators reportedly updated their threat assessment models to include scenarios involving artificial interstellar visitors. The mere possibility that an advanced civilization might be probing our solar system was enough to trigger enhanced surveillance protocols, even if the probability remained vanishingly small. As 3I/ATLAS began its journey back toward interstellar space, the scientific community found itself grappling with broader questions about how to handle future encounters with unusual celestial objects. The controversy had highlighted fundamental disagreements about the burden of proof required for extraordinary claims and the role of speculation in advancing scientific knowledge. Some researchers called for establishing formal protocols for investigating potentially artificial phenomena, while others worried that legitimizing such investigations would open the floodgates to pseudoscientific thinking. The economic implications of the alien probe debate also became apparent as private space companies began marketing interstellar visitor monitoring services to governments and wealthy individuals concerned about extraterrestrial surveillance. Several startups announced plans to develop specialized detection systems capable of identifying artificial objects disguised as natural phenomena, claiming that traditional astronomical instruments weren't designed to recognize advanced alien technology. Educational institutions struggled with how to present the 3I/ATLAS controversy to students and the public. Science museums found themselves caught between their mission to promote evidence-based thinking and the public's fascination with the possibility of alien contact. Several institutions developed special exhibits exploring both the scientific method and the search for extraterrestrial intelligence, using the comet controversy as a case study in how competing hypotheses are evaluated and tested. The media coverage of 3I/ATLAS revealed deep problems in how complex scientific debates are communicated to the general public. Many news outlets focused exclusively on the sensational aspects of Loeb's claims while ignoring the detailed technical arguments made by his critics. This selective reporting created a distorted public perception of the scientific consensus, with polls showing that nearly 40% of Americans believe the comet was probably artificial technology, despite overwhelming expert opinion to the contrary. International space law experts began examining the legal implications of potential alien reconnaissance missions, questioning whether existing treaties governing space exploration and planetary protection would apply to extraterrestrial visitors. The United Nations Office for Outer Space Affairs convened special sessions to discuss how the international community should respond to confirmed artificial objects entering our solar system, recognizing that such encounters might become more common as our detection capabilities improved. As autumn 2025 progressed and 3I/ATLAS faded into the distance, follow-up observations failed to reveal any of the dramatic revelations that either side of the debate had hoped for. The object continued behaving like a typical comet, gradually losing brightness and activity as it moved away from the sun's warming influence. No mini-probes were detected in Earth's atmosphere. No alien signals were intercepted, and no obviously artificial structures materialized from the cosmic visitor's icy shell. Yet the controversy left lasting impacts on multiple fields of study. The debate forced astronomers to confront their own assumptions about what constitutes adequate evidence for extraordinary claims, leading to new protocols for investigating anomalous phenomena. It highlighted the need for better science communication strategies that could convey uncertainty and ongoing investigation without feeding conspiracy theories or false hopes. The 3I/ATLAS affair also demonstrated how individual personalities and reputations can shape scientific discourse. Loeb's previous controversies colored how colleagues and the media received his latest claims, showing how scientific credibility can become both a valuable asset and a limiting factor in proposing unconventional ideas. The incident raised important questions about whether the peer review process adequately protects against both pseudoscientific speculation and overly conservative thinking. Perhaps most significantly, the interstellar visitor forced humanity to confront fundamental questions about our readiness for contact with extraterrestrial intelligence. Even the remote possibility that 3I/ATLAS might be artificial technology revealed deep divisions in how different societies, institutions, and individuals would respond to confirmed evidence of alien visitation. The controversy served as an unintentional rehearsal for the real challenges that would arise if and when humanity encounters genuinely artificial objects from other star systems. Religious communities grappled with theological implications of potential alien contact, while philosophers debated how confirmed extraterrestrial intelligence would affect human concepts of consciousness, purpose, and our place in the cosmic order. Psychologists studied public reactions to the alien probe claims, finding patterns of both excitement and anxiety that revealed deep-seated hopes and fears about humanity's cosmic significance. The entertainment industry quickly capitalized on the controversy with dozens of documentaries, podcasts, and fictional works exploring various aspects of the 3I/ATLAS mystery. These productions often blurred the lines between scientific speculation and creative interpretation, further complicating public understanding of the actual evidence and expert opinions. Social media platforms struggled to moderate content related to the comet, balancing free speech concerns against the spread of potentially harmful misinformation. Educational researchers used the 3I/ATLAS controversy as a real-time case study in critical thinking and scientific literacy. Students at all levels were challenged to evaluate competing claims, assess evidence quality, and understand how scientific consensus emerges from complex debates. The incident became a valuable teaching tool for demonstrating how extraordinary claims require extraordinary evidence, while also showing how genuine scientific uncertainty can be exploited by those promoting unsubstantiated theories. As 3I/ATLAS disappeared back into the depths of interstellar space, carrying with it the secrets of its distant origin, the scientific community was left to process the lessons learned from months of intense debate. The consensus among mainstream astronomers remained firm. The object was almost certainly a natural comet, albeit an unusual one that had provided valuable insights into the diversity of materials and processes occurring in other star systems. But Avi Loeb continued to argue that the absence of obviously artificial features didn't disprove the technological hypothesis. In his final papers on the subject, he maintained that truly advanced alien civilizations would likely possess stealth capabilities far beyond human understanding. The fact that 3I/ATLAS appeared natural might be exactly what its creators intended, allowing them to conduct reconnaissance without triggering defensive responses from primitive species like ourselves. The debate highlighted a fundamental challenge in the search for extraterrestrial intelligence. How can we recognize technology that might be millions or billions of years more advanced than our own? Traditional SETI approaches focus on detecting radio signals or obvious artificial structures, but perhaps truly advanced civilizations employ subtle methods that blend seamlessly with natural phenomena. If so, objects like Oumuamua and 3I/ATLAS might represent our first glimpses of alien technology hidden in plain sight among the countless natural visitors that pass through our solar system. As telescopes around the world returned to their routine surveys of the cosmos, astronomers knew that more interstellar visitors would inevitably appear. Improved detection capabilities and expanded monitoring networks virtually guaranteed that future encounters would provide better data and potentially clearer answers about the nature of these mysterious travelers. Each new detection would carry the tantalizing possibility of finally resolving the question that 3I/ATLAS had raised but left unanswered. Are we alone in the universe, or are we already being watched by intelligence far greater than our own? The legacy of 3I/Atlas extends far beyond the specific debate over its artificial or natural origins. The controversy served as a catalyst for broader discussions about scientific methodology, evidence standards, and humanity's readiness for potential contact with extraterrestrial intelligence. It revealed both the strengths and weaknesses of our current approaches to investigating anomalous phenomena, while highlighting the complex interplay between scientific inquiry, media coverage, and public understanding. Whether 3I/ATLAS was a chunk of ancient ice and rock from a distant star, or a sophisticated reconnaissance probe from an advanced alien civilization, may never be definitively resolved. But its brief passage through our solar system left an indelible mark on human consciousness, forcing us to confront profound questions about our place in the cosmos and our assumptions about the nature of intelligence in the universe. In that sense, regardless of its true origin, the mysterious visitor achieved something remarkable. It made humanity look up at the stars and wonder if we might not be as alone as we once believed. The scientific method proved both resilient and adaptable during the 3I/ATLAS controversy, demonstrating its ability to handle extraordinary claims while maintaining rigorous standards of evidence. Though the debate sometimes became heated and personal, the underlying process of hypothesis testing, peer review, and evidence evaluation continued to function as designed. The controversy ultimately strengthened rather than weakened our scientific institutions by forcing them to confront their own assumptions and improve their methods for investigating anomalous phenomena. As we await the next interstellar visitor, the lessons learned from 3I/ATLAS will undoubtedly influence how we approach future encounters with objects from beyond our solar system. Enhanced detection protocols, improved analysis techniques, and better communication strategies will help ensure that we're prepared to extract maximum scientific value from these rare cosmic messengers, whether they prove to be natural relics from distant worlds or something far more extraordinary. The story of 3I/ATLAS serves as a reminder that the universe still holds countless mysteries waiting to be discovered. Each new observation, each unexpected phenomenon, and each controversial interpretation brings us closer to understanding our cosmic environment and our place within it. Whether that understanding ultimately reveals a universe filled with intelligent life or confirms our apparent isolation among the stars, the search itself represents one of humanity's greatest adventures, the quest to comprehend the true nature of existence in an infinite cosmos filled with wonders beyond our current imagination.